At 3:20 UTC on August 16, 2026, a magnitude 6.1 earthquake struck roughly 56 kilometers northeast of Port Olry, a small coastal village in Vanuatu, detected by 75 seismic stations across the region. A magnitude 6.1 earthquake is objectively powerful, releasing energy roughly equivalent to 21 kilotons of TNT. And yet, as of this recording, there are no reports of damage, no injuries, and no tsunami warning was issued. That's not a contradiction, and understanding exactly why it isn't is one of the more useful things earthquake science can teach you. I want to walk through what actually happened, why this specific quake caused nothing, why a very similar magnitude event in the same country less than 2 years ago killed 14 people, and why Vanuatu appears in earthquake headlines more often than almost anywhere else on Earth. If you want earthquake news explained with real precision instead of either inflated panic or dismissive shrugging, subscribe, because getting this distinction right actually matters. Let's start with the specific facts, since precision matters here. According to the USGS, the earthquake's epicenter sat at roughly 14, 5 degrees south, 167, 2 degrees east, about 56 kilometers northeast of Port Olry, a village with a population of around 1,300. The quake registered magnitude 6.1. The number that explains almost everything about why it didn't become a disaster is its depth, 188, 1 kilometers, nearly 117 miles beneath the surface. USGS's automated pager system, which estimates likely casualties and economic impact within minutes of any significant earthquake worldwide, assigned this event a green alert, its lowest severity category, indicating no significant casualties or damage are expected. Vanuatu's Natural Hazards Department did not issue a tsunami warning. By every available metric, this was a powerful earthquake that essentially nobody felt in any meaningful way, generating only a single official felt report in the region. It's worth understanding exactly how a system like Pager arrives at that assessment so quickly. Since it represents real functioning infrastructure, most people never hear about outside of major earthquake headlines. Pager, short for Prompt Assessment of Global Earthquakes for Response, automatically combines an earthquake's magnitude, depth, and location with population density data and regional building vulnerability, estimates to generate a rapid casualty and economic loss forecast within minutes of any significant earthquake anywhere on the planet. A green alert specifically indicates a low estimated probability of significant casualties, based on precisely the depth and population factors involved here. Orange and red alerts are reserved for earthquakes where the modeled combination of shallow depth, strong shaking, and dense nearby population suggests a real likelihood of significant harm, triggering faster humanitarian response coordination, often before detailed on-the-ground reports have even arrived. It's also worth understanding the specific measurement behind the single felt report this earthquake did generate, since it illustrates how seismologists translate raw earthquake data into what a person actually experiences at a given location. Modified Mercalli intensity, or MMI, is a scale that describes the effects of shaking, as experienced by people and structures at a specific point on the surface, distinct from magnitude, which describes the total energy released at the source, regardless of distance or depth. This morning's earthquake produced a maximum estimated MMI of roughly 3.9, classified as light, the level at which shaking might be noticed indoors, comparable to a large truck passing nearby, but well below the threshold associated with any structural concern. By contrast, the 2024 Port Vila earthquake produced shaking-rated MMI 9. Violent, a difference of more than 5 full categories on a scale specifically designed to capture exactly the kind of real-world impact gap this comparison illustrates. 2 numbers, magnitude and MMI, working together rather than one substituting for the other, is really the core technical lesson this story offers. It's also worth noting what typically comes next after an earthquake like this one, since aftershock behavior is another area where public expectations often don't match the actual science. USGS aftershock forecasting models indicate that sequences from a magnitude 6, one main shock, can continue for weeks to months, gradually diminishing in both frequency and average magnitude over time, though the exact timeline and severity of any individual sequence can't be predicted with precision in advance. That's a genuinely different situation from the 2024 Port Vila sequence, where a magnitude 7, 3 main shock, roughly 16 times more energetic than this morning's event, produced over 300 aftershocks specifically, because the initial rupture itself was so much larger, generating far more residual stress along the surrounding fault system that needed to be released over the following weeks. So why does a magnitude 6, one earthquake, releasing that much energy, end up causing nothing at the surface? The answer comes down almost entirely to depth, and it's worth explaining clearly, since it's one of the most consistently misunderstood aspects of how earthquake magnitude translates into real-world impact. Seismic energy has to travel from the rupture point, called the hypocenter, up through crustal and mantle material before it reaches the surface where people and infrastructure actually exist. The deeper that starting point, the more solid rock the waves pass through, and the more that energy naturally disperses and weakens en route, spreading across a much larger volume of material before reaching anyone at ground level. A shallow earthquake, at 10 or 20 kilometers, concentrates nearly all its destructive energy directly against the surface above the rupture. A quake at nearly 200 kilometers depth, like this one, releases that same raw energy so far underground that by the time it reaches the surface, it's been substantially absorbed and scattered by intervening rock. It's worth going a bit deeper into the physics here, since deep focus earthquakes are a genuinely interesting area of ongoing research in their own right. At depths beyond roughly 70 kilometers, surrounding rock sites under such extraordinary pressure and heat that, according to the basic physics of brittle rock fracture, it shouldn't be capable of the sudden sharp slip that produces an earthquake at all. Rock that deep should behave more like a slow-flowing material than something that cracks. Yet deep focus earthquakes, some occurring at depths approaching 700 kilometers, happen regularly around subduction zones exactly like the one beneath Vanuatu, where one tectonic plate is forced down into the mantle beneath another. Scientists still debate the precise mechanism, with leading theories involving mineral transformations within the descending plate that trigger a sudden, localized collapse in volume, functioning like an earthquake even though the rock is far too hot and pressurized for conventional brittle fracture. This morning's quake, at 188 kilometers, sits within that still not fully understood category. One more data point for researchers, studying how subduction zones actually behave at depth. Vanuatu itself provides one of the clearest, most tragic real-world demonstrations of the opposite scenario, and it happened less than 2 years ago in the same country. On December 17, 2024, a magnitude 7.3 earthquake struck near Port Vila, Vanuatu's capital, at a depth of just 4 kilometers, dramatically shallower than this morning's event. The difference in outcome was substantial. That earthquake killed at least 14 people, injured 265 more, with additional people reported missing in the immediate aftermath. It generated a 25-centimeter tsunami and produced shaking classified as MMI 9, officially described as violent, strong enough to collapse buildings, crush vehicles, and severely damage the complex housing the US, UK, and New Zealand embassies. 2 large reservoirs supplying Port Vila's drinking water were destroyed, cutting off clean water to the capital for days. Total damage has been estimated at over 231 million. More than 300 aftershocks followed in the days after, the strongest reaching magnitude on 6. One, essentially identical to this morning's event, but at a depth roughly 3.5 times shallower. That comparison is the actual lesson at the center of this story. 2 earthquakes, both magnitude 6.1, both in Vanuatu, releasing essentially the same raw seismic energy. One produced a green alert and a single felt report. The other, part of a sequence that struck at shallow depth directly beneath a populated capital, contributed to a disaster that killed 14 people and cut off water access for an entire city. Magnitude alone, the number that dominates every earthquake headline, tells you only part of the story. Depth, distance from population centers, and local ground conditions shape the real-world outcome just as significantly, sometimes more so, than the raw magnitude figure most coverage fixates on. So why does Vanuatu appear in earthquake news with this kind of frequency in the first place? It comes down to exactly where this island nation sits geologically. Vanuatu lies directly along the Pacific Ring of Fire, the horseshoe-shaped arc of intense seismic and volcanic activity tracing tectonic plate boundaries around most of the Pacific Ocean. Specifically, it sits above the New Hebrides Trench, a subduction zone where the Australian plate is being forced beneath the smaller New Hebrides plate at a comparatively rapid geological pace. That ongoing collision is why Vanuatu experiences earthquakes with a frequency most of the world would consider extraordinary, and it's the same general system responsible for the largest earthquake ever recorded in the country, a magnitude 7.9 event in October 2009. This near-constant seismic activity is a major factor in why Vanuatu has been repeatedly ranked in the United Nations University's World Risk Report as the single most disaster-prone country on Earth, a ranking it's held consistently since the index launched in 2011. That ranking doesn't come from earthquakes alone. Vanuatu, a nation of roughly 330,000 people, spread across around 80 islands, faces an unusually concentrated combination of hazards, powerful cyclones, active volcanoes, rising sea levels, and persistent seismic activity, layered on top of comparatively limited infrastructure and resources for responding to major disasters when they strike. There's a human dimension to this worth acknowledging directly, beyond the raw statistics. Aid organizations working in Vanuatu consistently describe its population as remarkably resilient, having developed genuine practical and cultural experience responding to cyclones, volcanic activity, and earthquakes across generations, precisely because these hazards recur so regularly. In the aftermath of the 2024 Port Vila earthquake, that resilience showed up directly in the response, with the Vanuatu Red Cross Society and National Disaster Management Office coordinating rapidly alongside international partners, including Australia's Disaster Assistance Response Team, which deployed firefighters, paramedics, and search and rescue teams within roughly a day of the quake. That combination of extraordinary exposure paired with practiced resilience is part of why Vanuatu remains such a heavily studied case for disaster risk researchers, and it's part of why a routine, damage-free earthquake like this morning's still gets tracked and reported by monitoring networks globally, even when the outcome is, thankfully, nothing. This morning's earthquake also didn't happen in isolation. Just one day earlier, on August 15th, a magnitude 7.7 earthquake struck Indonesia, another nation along the same broader ring of fire system, killing dozens of people and triggering hundreds of aftershocks in the following days. Two major earthquakes in two different Pacific nations within roughly 24 hours of each other, occurring along different sections of the same interconnected system of tectonic boundaries responsible for the overwhelming majority of the world's most powerful earthquakes. It's a genuine reminder of how seismically active this region remains at essentially every moment, even when most of that activity, like this morning's Vanuatu quake, passes almost entirely unnoticed outside specialist monitoring circles. So here's the accurate version of this morning's story. A genuinely powerful earthquake, magnitude 6.1, releasing energy on the scale of a small nuclear weapon, struck one of the most seismically active and disaster-prone nations on Earth, and caused essentially nothing. No damage, no injuries, no tsunami, a single felt report. That outcome isn't luck. It's physics, specifically nearly 200 kilometers of solid rock standing between the rupture and the surface, absorbing and dispersing energy that, at a shallower depth, has already proven in this exact country, less than 2 years ago, capable of killing people and leveling infrastructure. Understanding that distinction is exactly the kind of knowledge that helps you read the next earthquake headline accurately, rather than assuming every large magnitude number automatically signals disaster, or dismissing every damage-free earthquake as unimportant. If you found this useful, subscribe and turn on notifications, because Vanuatu and the wider ring of fire it sits on will keep generating stories like this one. Let me know in the comments if you knew depth mattered this much in determining earthquake damage, and if you know someone who assumes every large magnitude number automatically means catastrophe, send them this video.